Okay.
So, physical change, huh?
What is the difference between a physical and chemical change?
Okay, apparently someone got hungry. But this is a physical change because Brenda ate it, but still,
It's still
it's still the Danish, still the strawberry, delicious
a
Danish.
cheese and berries Danish.
It's still a Danish. Capiche? You can eat it now. Mhm. That's right, baby.
And when I digest it and everything, once it goes into my stomach and starts digesting and decomposing, that becomes a chemical change because it's no longer Danish. It's now being broken down into minerals and vitamins for my body.
So, yeah, it digests. Chemical change. Not Danish anymore. It's going to turn into what you see in the toilet.
Afterwards, yeah. The differences between intensive and extensive properties. For example,
The color is intensive.
because it does not depend on the amount of matter.
Mhm. Next.
Next is extensive properties. Now, extensive property, it does depend on the amount of the matter. For example, volume. In this cup, it contains
Blue Powerade.
blue Powerade,
And I don't know if you can see it.
it's like half.
Yeah, just a tip, just a tip. Oh, yes. It's a beautiful color, right?
Volume of the drink
Expensive.
is extensive because it depends on how large the cup is, how much it can contain, or how much is already in the cup. That is the difference between extensive and intensive properties.
Difference between a pure substance and a mixture.
A pure substance consists of only one element. For example, an oxygen tank full of oxygen atoms. Or for example, in our case, since we don't have an oxygen tank,
Because we're poor.
lead.
It's lead.
Lead is this little piece of lead
Is a pure substance from the periodic table.
A mixture
is something like this. I don't know. It's a muffin, blueberry muffin, and it's no ordinary mixture. It's a hetero mixture. Because the blueberry, you can still see the blueberry in the muffin. See, consists of two different things.
And you can separate them, like a Caesar salad.
And now what Brenda has is the Powerade, remember? Mmm, tasty.
No.
It's a homo. Yeah.
Why is it a homo? Why is it a homogeneous mixture?
Because it doesn't have different particles inside there. Different particles that can be separated.
That can't be separated.
Can't be separated. Yes. Thank you, Brenda.
It contains, the powder to make the blue Powerade, and of course water and lots of other artificial flavors. Mix it all together, and well, it becomes a homogeneous mixture. Why?
Because it's just gay.
That and because you just can't separate all those, particles that were mixed into it. Unlike the blueberry muffin, you can pick out the blueberries or you don't like the blueberries.
Blueberry. What? So, where are the alkaline metals, alkaline earth metals, transition metals, halogens, and noble gases? Oh. Well, first of all, let's start with the alkali metals, which spelled with an I, are right here with lithium, sodium, and potassium. Yeah. So they're right here. They're the most active elements in the whole periodic table. And here are the alkali earth metals. which yeah, they're right there with um with
Beryllium,
magnesium
magnesium.
and okay. And here are the transition metals with iron, mercury, and all that neat stuff, and gold. And here are the halogens, fluorine, chlorine, and bromine, iodine. And here are the famous noble gases, helium, oh, sorry, let's start with neon, argon. And they're most famous because they have the complete 8 valence electrons that everybody wants to have right here. So, stop. Yeah, yeah.
Electronegativity is basically it's measuring the tendency of an atom to attract a bonding pair of electrons. And the way it is seen, or the trend that is seen here on the periodic table, is that starting from here at this very bottom, from this element, I believe rhenium, is the has the least electron negativity. And then it just works its way all the way to up to this corner, uppermost corner, to the right of the periodic table, to fluorine. So that's one easy way of kind of knowing, having a good idea of what the negativity trend is on the periodic table. The atomic radii that is seen, or the atomic radii trend that is seen on the periodic table, basically what it is, which is the atomic radius, it is measured from the nucleus to the most outermost valence electron, and that creates a size of the atom. And as you can see here, from top to bottom, the atomic radii increases, and from left to right, it decreases. It goes from big to small. So top to bottom, small to big, left to right, big to small.
Well, I hope you actually learned from this.
So this concludes our video over matter and the periodic table. So I hope you enjoyed and I hope you learned some things. And well,
This is Marissa.
and I am Brenda.
We're out.